Hi, my name is Chris Schaffer, and I'll be walking you through my Homework 2 assignment for CSC 578. So this is the Jupyter Code notebook. It's saved as an HTML, which I'll submit. First up in this cell, we import the modules that we need. Next cell has some of the helper functions. I think the only one I pulled in from elsewhere was this myload CSV, which I found useful for experimenting with later. But the rest of these came with the code. Next cell is the cost functions. The quadratic cost was already written, the cross entropy cost was filled in, and the log likelihood was placed here as well, both the function and derivative. Next we have the activation classes. Sigmoid was there, softmax was partially implemented, and tanh and ReLU are both added. The softmax is a little weird because it returns a matrix here for the derivative and a vector here for the function itself. Instead of just typical values and vectors, we have a vector and a matrix. Next up is the main network class. Some additions were made up front here to accommodate and implement dropout as well as regularization. So the dropout percent is assigned here, and after that we go and create a dropout list. This was my addition. Um, This dropout list is ideally a list of lists that are one-hot encoded vectors. The vectors are assigned 1 or 0 based on the percent that the user inputs to the network class. And then these get shuffled later on, as we'll see. Next up is the set parameters function. A couple catch functions, or not functions, but if statements catching inappropriate combinations of parameters are set here, and they're pretty explanatory what they're doing. Here we see the dropout list again. It's both in the set parameters function and the init function. Next, the feed forward is modified to implement the dropout lists. The way it does that is if dropout is implemented here, it multiplies the one-hot vectors by the values of the activations, effectively killing or maintaining those particular activations each time we feed forward. The next time around, they'll be shuffled and a potentially different set of uh, activations will be maintained and canceled. Next up is the SGD function. Not a whole lot of changes here, but the update mini batch was modified to, like I said, include the dropout list and shuffle those one-hot vectors. Here we update the weights and biases. Backpropagation was modified a bit to accommodate the addition of softmax since it has some exceptions of its own. Here we see if the output is softmax and only the output is allowed to be softmax. C prime has this assignment versus the regular assignment, and delta is calculated slightly differently. That delta then cascades down into these results here, and that's how we end up with our either softmax or typical results. I guess anything other than softmax. Accuracy wasn't really touched. The total cost function, however, was in order to include regularization terms here. L1 and L2 are the only options at the moment, but they are calculated in pretty similar ways here. Next up is the cell containing the experimental code. These are the different networks, the 12 different networks that were in that table in the homework assignment itself. These are the user set parameters here. We have ADA, batch size, and number of epochs. Since those weren't specified, they're just held constant throughout here. Each and every network has the same set of these parameters. So then next, after we make the network parameters here, we then run the code. I have imported the iris train and iris test data sets. Here you can see I was playing around with trying to use different amounts of that training data to get better results. Here we produce the results, which you can see down here. We summarize what network it is, the parameters that go into it, and its accuracy and performance. And then down here is a little bit of code to help me save those results to a CSV, which then went into here. This is the PDF or Word document that I'll be submitting along with my code and this video. We have the results up front here and some discussion and summary of the results following. Thank you for your time. I hope you have a good day.